All right, all right, all right. Good evening to good evening, good evening, good evening to all the grade 10 students. How are you all doing, students? All right, to all the new students, welcome to the series, welcome to the channel, welcome to the platform. Yes, this is your Vani ma'am, and all the old students who are watching, give me a smile, student, that gives me energy. Yes. So today we are going to do a topic called human respiratory system. Yes. As you have seen, all right, okay, can you recognize this person? The most famous cricketer, right? The proud moment, his pride to a nation, all right? But they also have problems, correct? What is that problem? They are just asking you question. Why do cricketers get cramps? When they're playing, they get cramps, they get muscle cramps. Suddenly they sit and say, my God, it's paining. Do you know why it is? Shall we discuss this? Yes, we are going to discuss everything, minute things, students. We are going to see a general discussion also. We are going to see your topic, every line of NCRT. Let's do this question. So normally what happens, whenever a cricketer or any sports person plays, you very well know this flexibility of muscles, right? Just see, when this person is running or jumping or doing heavy exercises, what does he require? He requires a lot of energy, correct? Okay, energy indirectly says oxygen, ATP. Okay, energy is ATP. Indirectly, if I have to say, he requires a lot amount of oxygen to move ahead, correct? So that lot amount of oxygen, when he is running, jumping or something, will it be less or more? Yes, it will be more. During running, the most important thing is the amount of oxygen requirement is highly, it is the highest peak, correct? Yes. Then what happens inside the body, inside the muscles, whatever glucose is there, because the stored food, glucose is your stored food. The stored food, what happens, the stored food gradually or immediately, I want energy, immediately I want to give the ATPs to the body. So what it does, the stored food, whatever is there, what is stored food in the form of glucose? That's nothing but C6H12O6. That C6H12O6, now its work is to give oxygen, because the sports person is asking for that oxygen because he has to run. So this immediately, this stored food, instead of getting converting into your carbon dioxide water during running or during anything, any exercise, it converts into an acid called lactic acid. Yes, this lactic acid gives me the pain. So this lactic acid starts depositing in the muscles. Wherever you're seeing, no, you're able to see this muscle cells. So here this person is having cramp. Here, this is the lactic acid structure. That lactic acid goes and deposits there at the cramp, wherever is there. Because of this lactic acid deposition inside your muscles, the particular cricketer or any sports person, they get pain. Acid, no, it gets pain. So, because of this lactic acid, this one, you get pain. But how can this be relieved? If this person or this particular runner, if he takes rest for some time, automatically the lactic acid deposited little bit gets vain out. Easy, students, easy, very easy concept it is. So more amount of oxygen, which respiration is acting now? Anaerobic respiration, because oxygen supply is more required. Anaerobic respiration is a concept which converts glucose to lactic acid. So this is the concept. That's why you're able to see. Oh, he is feeling that pain here. He's holding his hand here. He's feeling that pain. So what is released now? Heated lactic acid is released. And which type of respiration is going on? Anaerobic respiration. Without the presence of oxygen, this respiration is going on in this. Easy peasy, easy peasy. So let's go into more and more interesting facts, students. Let's start the concept. The concept here today, we are going to read many questions. After you learn this concept, you will only be able to answer how is oxygen and carbon dioxide transported in human beings. Yes, this question is always important for us. I'll make you understand. How are lungs designed in human beings? Yes, how are their lungs designed? How are they exchanging gases? Everything I'm going to discuss. Let's start the video. Very interesting. I request all of you to please like the video, share the video, and subscribe to the channel. You can be with me for 10th class, 11th, 12th. My journey with you all is forever, students. Yes, let's start. First of all, I have to understand what actually is respiration. Basically, respiration, all right. Respiration is a process, students. Basically, just like your digestion, like your excretion, like your nutrition, this also is a process. Okay, what is happening in this process? Whatever food you are taking inside your body, your food, why are we taking food? To get energy, correct? Na? So, here during this conversion of food to energy, what is required? It requires oxygen. So, basically, your respiration is a process of converting food to get energy by utilizing oxygen. So, can I call respiration as an oxidation process? Oxidation means what, students? Addition of oxygen. So, respiration is an oxidation process in which food is getting converted to energy by utilization of oxygen. That's respiration. So, where is this all happening, ma'am? This conversion and everything, where is this happening? The location in our body is it is happening in mitochondria. Mitochondrions. Okay, so mitochondrion, what will happen here? In mitochondria, whatever this energy is there, na, this energy is released in the form of ATP. What is ATP? Adenosine triphosphate. This energy goes and stores here. It is stored. So powerhouses is what we call them. Mitochondria are powerhouses. So whenever you require energy, you can get that energy from this mitochondria. So simple definition, easy definition. I can write this definition directly in the exam. Easy? Easy. Now, after this respiration is over, okay, I got an understanding. Food is converted in energy. Now, I have to know what are the different types of respiration which we have in our body. Basically, we have only two types of respirations. One is which is aerobic respiration. Aerobic respiration. REPRISATION. One more is anaerobic. This is aerobic. One more is anaerobic respiration. Anaerobic respiration. Ma'am, what actually is this? How is it different? What it is? Let us see the differences. So, how many types of this one we have? We have aerobic. One more is anaerobic. Anaerobic. So basically, students, in both the cases, concept is respiration only. But here, the pyruvic acid, whatever we have in aerobic respiration, first of all, if I have to be clear with the examiner, I'll say aerobic respiration happens in the presence of oxygen. The first most important thing is this happens in the presence of oxygen. Okay. Anaerobic respiration in the absence of oxygen, in absence because without oxygen only this respiration goes ahead. So, ma'am, what is the difference between both? Simple thing you have to remember. In case of aerobic respiration, I'll tell you what is pyruvic acid also in a while. So, just as of now, remember pyruvic acid here in the presence of oxygen, it gets converted to carbon dioxide in aerobic. But in case of anaerobic respiration, your pyruvic acid, whatever is there, it either gets converted to your ethyl alcohol. Okay, ethyl alcohol is one product, or it may get converted to lactic acid, as I said, for your sports person, yes, where lactic acid is generated. So in this case, I'm using oxygen and forming pyruvic acid or carbon dioxide. Here I'm using, I'm not using oxygen, I'm getting ethyl alcohol, lactic acid. And what is the reaction? Now see, students, you have your glucose in your body. Let us see the reaction in the exam. This is important. You take your food, the basic food, the carbohydrate, what is there? How is it stored in the body? It's stored in the body in the form of glucose. Correct? Glucose. So this is taking oxygen. This is taking oxygen. This is forming in many steps, step by step, many steps which we are going to learn in detail in the upcoming chapters. In many steps, it's going to convert into carbon dioxide molecule. It's going to get converted into water molecule, and it's going to generate ATP energy. This is your usable energy. This is your usable energy which you require. So if I have to balance the reaction, carbon is 6 here, so I'm putting 6 here. Hydrogen is 12 here, so I'm putting 6 here. Oxygen is 6 plus 6, 12, so 6 here. So how many ATPs? 38 ATPs are released in the reaction. So this is ATP is nothing but your energy source. So this ATP is what is used for our respiration or for our body to work. But in case of anaerobic respiration, the same food what you are taking, your glucose C6H12, your O6, your glucose or your food, whatever is there, glucose. So in very few steps, this is in many steps, this is in few steps. So in few steps, it's going to convert into lactic acid. convert into lactic acid. So 2 moles of lactic acid you get, and along with this, the amount of ATPs is 2 ATP. So this is again your usable energy which is there for your respiration. So this is your respiration definition. This is your aerobic and anaerobic definition. And in anaerobic, where basically it is found, students, it is basically found in your microbes. Okay, microbes. It is found in your muscle cells. As I said, muscle cells. I told you, no, anaerobic respiration, you'll be getting the cramps. Yes, right. But here further, when I take this aerobic and anaerobic respiration, for example, unicellular organisms, can I use the next page? Okay, we are going to study the respiratory system. Let me take this. In unicellular organisms, diffusion process takes place. In plants also, diffusion respiration is in the form of diffusion process. Now tell me, in fishes, what we are using? Gills. Correct. In insects, spiracles we are using, trachea we are using. And terrestrial animals, what do I use? I use lungs, correct, right? So these are the different types of respiratory organs which we have. Correct, students? All right. Now, with the basic respiration, types of respiration, now I'm going to take you into a concept called human respiratory system. Wow, just beautiful diagram, isn't it? Yes. Human respiratory system starts with your nose or the nasal cavity. Nose, it's called the nasal cavity. From there, it enters through the or it connects the oral cavity, that's nothing but the mouth. From there, gradually, when we come, it connects with your throat. When that particular throat part region is called as pharynx. Gradually, it comes to your larynx. This one, this is your larynx, students. This larynx, this is called voice box. From there, it connects to pipe-like structure, that is nothing but trachea. From there, it enters into the large bronchus. You're able to see, students, bronchus and bronchi. Airways, bronchi. All right, the part. So bronchus, which are branched in nature, the trachea connects to the bronchus. Then comes both the lungs, right lung and left lung. This is your respiratory system parts. So this respiratory system is again divided into two parts. How is this? We have upper respiratory tract and you have lower respiratory tract. Upper respiratory tract includes nose, nasal cavity, sinuses, larynx, and trachea. The lower respiratory tract includes lungs, bronchi and bronchioles, and air sacs. That's nothing but alveoli. All right, students. So when they ask you respiratory system, write it in the two different parts, upper and lower. Now, when I take this, careful, the first organ is nostrils. You're able to see this nostril, students? Yes, nostrils. Those, how many nostrils do we have? Two nostrils we have. This is one nostril. This is the second nostril. So both the nostrils put together, they converge into a passage. They converge, put together means both together. Converge means, you know, right? Mixed together or put together. They enter into a passage called nasal cavity. Nasal cavity. This is your nasal cavity. From the nasal cavity, gradually it enters into here. I'll show you in this diagram also. In this diagram also, you'll understand. See this. Your nostrils, they converge into your nasal cavity. Into one cavity is what they enter. So that particular nasal cavity gradually enters into the next part, as we have seen just now. Just see here, where is it going? It's entering into your nasal cavity, is entering into your throat or the pharynx. Correct, right? Okay. Now, first thing, important thing, what question they ask here? Let us write what question they ask here. First question is, nostrils converge into, okay, nostrils, they converge into nasal cavity. Okay, nasal passage. Okay, this is the first part which we should remember. Okay, the next part, students, next part, important thing, inner lining of your nasals. When you see, it has two things. What is that? First important thing, it has hair inside the nostril. It is also wet inside your nostril, right? It is also wet. So hair and wet. First of all, what is the role? Why is it wet? Let us answer that. Because it has secretion called mucus secretion. Okay. But mucus secretion. Now you only tell me what is the role of hair? Hair will filter all the dust particles. Correct? And what is the role of your moisture, wet? Because the wetness or the inner layer moisture, it will try to keep your temperature of your particular nose, right? Yes, when the examiner is asking before we go to the pharynx, remember two things here. First thing is nostril enters into nasal passage. It has hair and it will keep them moist. What is the role of hair, students? Hair tries to filter the dust particles. Filter the dust particles. It will filter the dust particles here. What is the role of your mucus secretion? Will try to maintain the moisture and temperature of the particular organ, temperature of the particular organ. Perfect. Yes, done. Next from there, next cavity is pharynx. Now you only tell me, students, how is a pharynx? So nostril is over. Gradually from nostril I am entering into a cavity called pharynx. This is the pharynx. How is your pharynx looking like? Pharynx is a tube like structure, correct na? It is a tube like structure which I am able to view with my eye. Tube like. What else? From pharynx, where is it going? Gradually pharynx is entering into a cavity called, or entering into a particular passage called larynx. Continues to larynx or nasal passage. Yes, so pharynx basically tube like structure. Whatever is there, it continues to the nasal passage. This is the connectivity, if you think, it's a connectivity to the nasal passage or the larynx. Done, students? Can I write nasal passage to the larynx? Yes, you can understand seeing the diagram. Okay. From the pharynx, you only tell me what is the next thing. Next is larynx. Just the next part is this. So where is larynx? This is your larynx. Where is your pharynx? This is your pharynx. So when the examiner asks you, you should just simply, larynx is nothing but your voice box. Larynx, the other name is voice box. Where does this voice box come? Larynx comes after pharynx, correct? So you can write in the examiner, the location of this is after pharynx. After your pharynx, your larynx comes. Larynx comes. Perfect. Yes, this is what you can say. Simple. From the larynx, where is it going, students? It is going into an organ called trachea. Remember, now we are going to study about a concept called trachea. See this: esophagus, pharynx, larynx, and now trachea. Now, what are you observing here? Trachea. See here, students. Trachea. See, what are you observing here? Yes, trachea are rings of cartilage. That is the most important thing. Rings of cartilage. Okay, rings of cartilage. What is the role of this trachea? What does it do in our body? Yes. So when, see here, this rings are holding the rib cage or no? Yes, it's holding the rib cage. It's holding the it is holding the trachea or no? The particular the rings inside are holding this trachea intact. So what is the role of cartilage? The role of cartilage is it prevents the collapse of trachea. So when the trachea will collapse in the absence of air, when the air is not there, what does it do? It immediately holds the trachea and it will not allow the trachea to collapse. It will hold it intact. Easy? Okay. Now from trachea, where are we going? Our journey grows into a concept called bronchi. See here. This is your trachea, students. From where? Trachea. From that trachea, I am entering into bronchi. So how many bronchi do we have? This is one and this is one. So bronchi are pair. Okay. Pair of bronchi. Pair of bronchi. Bronchi. Where are they coming from? They are coming, a pair of bronchi coming out from trachea. Correct na? Yes, the trachea which is there above, they are coming out from trachea. So after that, where are they branching into? Bronchi are branching into bronchioles. Correct na? They're branching into bronchioles. Where they are branching, this bronchioles are going to both lungs. Both the lungs. Am I right, students? Both the lungs, the bronchioles are going. Now, what is that bronchioles? What are they doing? Before we go into the alveoli, if they ask you what are bronchioles, so bronchioles are the branches which are present inside the lung. Shall we write bronchioles are branches? Shall we write here? Bronchioles are branches which distribute or spread into the lungs. Okay. After they enter into the lungs, what is the next thing? Alveoli. Very important. What is it? Alveoli. Alveoli. You're able to see trachea is over. Then we have seen bronchioles, no, bronchi, I said. After bronchi or bronchus, it's entering into bronchioles. After bronchioles, we have something called alveoli. See here, alveoli. Now you tell me, alveoli, how are they looking? Alveoli basically are air sacs. Air sacs. Where are they present? They're located at, you will tell me, located at end of, they're located end of bronchioles. Bronchioles, correct? And they're located end of bronchioles. See here, end. Every corner, tips they have. So this alveoli, what are they made up of? Please remember, this is the most important thing. Alveoli are made up of blood capillaries. So alveoli are composed of thin membrane and blood capillaries. So made up of, what is the role we'll learn now? Made up of thin membrane. I'm also teaching you answer writing skills, and so that it's easy. Thin membrane and blood capillaries. Thin membrane and blood capillaries. Okay. What is the role of this alveoli? Role. What is the role of this alveoli? Now you only tell me, students. Alveoli, from the alveoli, the exchange of gases takes place. So oxygen combines with your blood, yes, and goes inside, and carbon dioxide comes outside. So here in alveoli there is exchange. So why this happens? Why this exchange of gases is happening? Because of the pressure difference. Shall we see this diagram? See here. This is your expanded view. What is happening in this alveoli, which is at the tip of the bronchioles? Oxygen is entering inside and carbon dioxide is going out. Yes or no? So exchange of gases in alveoli. Why does it happen? Happens due to happens due to pressure pressure difference or pressure differentials or pressure difference. So because of this pressure difference, which goes inside, students, oxygen combines with blood and it goes inside. Carbon dioxide gets expelled out. And students, easy, easy. Now you see, what is the breathing mechanism? How does breathing mechanism happen? How do we exhale and inhale? Just now I said oxygen comes inside and carbon dioxide goes out. Now you see, students. Basically, we have studied about the nasal cavity, trachea, pharynx, trachea, then your bronchiole, then bronchioles, then alveoli. Now what happens is during breathing, so breathing mechanism basically is controlled by what? It is controlled by two things. So breathing mechanism is controlled by two things. What is the first thing? It is controlled by lungs and it is also controlled by intercostalis muscles. What is that called? Intercostalis muscles or and lungs. What is this? So basically, you're able to see something, students, here. Diaphragm below the muscles. Diaphragm below the muscles. See here. So what happens is diaphragm, when it contracts. See here. When the diaphragm contracts, you know, right? Comes closer. So when the diaphragm contracts closer, automatically air is exhaled out. Once again, students, once again, let me see here. How should I remember? How will I make you understand? I'll make you understand like this. See here. First, diaphragm moves up. We'll start with up. Okay, diaphragm moves up. Where is the diaphragm moving up? Here. See here. Diaphragm moving up. Diaphragm is moving up. When diaphragm is moving up, what will happen? This is pushing up, 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 and air is exhaled. You exhale out the air. Diaphragm moves up means air is exhaled. It is pulled out. Done? This one. Suppose diaphragm is moving in, moves down, and the diaphragm is moving down. Like this, you do know, inhaling and exhaling. So diaphragm is moving down. So when diaphragm is moving out, what will happen to the lungs, students? Lungs will expand, lungs will expand, and air is inhaled. It is taken inside. So shall we once check what it is? Once again, we will write three things we will write. First, diaphragm moves, your diaphragm moves down. Here, diaphragm moves up. 1 second, students. I'm getting a call. All right, students. All right. So, little bit a small disturbance. Sorry for that. So here, in this case, diaphragm moves down is what we have written. Here we write diaphragm moves up. In both the cases, whenever diaphragm moves up or down, what will affect, students? First of all, your lung is where your expansion or contraction happens. Correct. So when the diaphragm is moving down, remember, lungs are going to expand. Correct. You're applying pressure on a balloon, so it will expand, right? So when the diaphragm moves up, lungs are going to contract. Remember. Okay. Now when something is expanding, what will happen to the air? You the capacity increases. So air inhalation happens. Air inhaled or air inhaled. Air starts going inside because it is giving more surface area. In this case, when the lungs contract, air, whatever is there, air is exhaled. It's coming out. It is in opposite direction. So diaphragm is down, moving down. Air is inhaled. Diaphragm is moving up, air is exhaled. Remember this concept. Easy, students, very easy, very easy. So the complete respiratory system, whatever is there, the complete concept I have discussed today. Let us once summarize what we have studied. The summary part here is, first, I have taught you why do the cricketers get that cramps? They ask you this question. Why do they get that cramps is what they ask you. Then I have taught you a concept of what is meant by respiration. I have taught you the concept of types of respirations. I've taught you the concept of I've taught you the concept of complete respiratory system in human body. Respiratory system in a human body. Correct, na? So human body, respiratory system, human body is what I have taught. Then for human body. Then I also taught you with the breathing mechanism. So I'll meet you in the next video, students. Please tell me what is your requirement. What do you want me to teach you further? Yes. And I also have one more important thing. Please join the telegram. Join the telegram. The telegram channel link is here, because after the video I'm going to share you notes. I'll share you notes, students. So the notes, complete notes, along with what notes will be there, MCQs will be there, short answers will be there, very short will be there, all. I'll also be sharing you a lot of YouTube shorts. You will enjoy the shots. Yes. So signing off with a beautiful smile. Bye bye. Take care. I request you to like the video. I request you to share the video. I request you to share your comments, valuable comments. Bye bye. Take care. Thank you.